Hello, we're the students of 10th grade, and today we will talk about pi, its history, where it comes from, and its earliest forms. We will give real-life examples on how to use pi and also talk about its importance for us as a society. We hope you enjoy, and most importantly, learn something new. The earliest known reference to pi comes from ancient civilizations, such as the Egyptians and Babylonians. In ancient times, documents such as the Radian mathematical papyrus found the area of a circular shape in a curious three-step manner. First, finding the diameter and then subtracting the circle's ninth part. The Radian papyrus, circa 1650, gives us insight into the mathematics of ancient Egypt. The Egyptians calculated the area of a circle by a formula that gave the approximate value of 3.1605 for pi. The first calculations of pi were done by Archimedes of Syracuse, one of the greatest mathematicians of the ancient world.
The first reference to the number pi dates back to the culture of ancient Egypt, when they calculated that the approximate value of the constant was 3.160. In the ancient region of Mesopotamia, scientists and astronomers reached a value of 3.125. In the 3rd century, the Greek mathematician Archimedes managed to make a much more precise calculation of the value of pi. In the years after Archimedes, other Greek mathematicians managed to approximate the value of pi to 3.1416. For the centuries, the system devised by Archimedes led to the discovery of more decimals of pi. They just had to enlarge the numbers of sides of each polygon to fit the actual value. The Chinese mathematician Liu Hu estimated the value of pi at 3.14159 in the 3rd century, and Su Zhongxi added 2 more decimal places in the 5th century, more than 1,000 years after Archimedes' death. In the 17th century, the Japanese mathematician Takebe, he managed to calculate up to 41 decimal places of pi using a 1024 sized polygon.
In this segment, we're going to talk about the use of pi in the present. In our present-day mathematics, both in school and college, pi is used to find the area being the amount of space taken up by a 2D shape, and the circumference, the enclosing boundary of a curved geometric figure, specifically a circle. You yourself might not use it every day, yes, that's true, but pi is used in most calculations for building constructions like new schools or new houses and homes. Quantum physics, communications, medical procedures, which are very important, air travel, and many, many more.
Pi is an irrational number with infinite decimal places and is a very important mathematical constant, indispensable for calculating and drawing the circumferences that appear in all ocean contours. Today, the number pi is used in the manufacture of common objects such as tires, cookies, watches, and bottles. Any circular object with a diameter and a perimeter. The popularity of pi has made the figure appear in a plot of many series, such as The Simpsons, Futurama, and Big Bang Theory. It also appears in the title of many movies and novels. It has also served as artistic inspiration. Each number 0 to 9 is replaced by a color, and the resulting work represents the infinite sequence of decimals with those colors in order.
And now we're going to know some facts about pi. First fact, where did the symbol come from? Pi is a Greek letter pronounced like the English letter P and means perimeter. Second fact, humans' first calculate was about 3,000 to 4,000 years ago. Third fact, in 2009, Congress officially declared March 14 Pi Day in recognition of the importance of math, science, and education. Fourth fact, how many digits are in pi? Pi is infinity, meaning it never ends. Pi is a rational number. 5 fact. Evidence reveals that the design of the pyramid of Giza embodied to the pi and the Pythagorean theorem. Interestingly, some of the most science in the world have a connection to Pi Day. Like Albert Einstein was born on March 14 in 1879. and Stephen Hawking died on March 14 at the age of 76.
To know how pi was created, we need to know the concept of two measures, radius and radians. The radius of a circle is any line segment that connects the center of the circle to any point on the circle. The length of the radius is half the diameter.
And the radian is a unit of measure that comes from the radius of the circle. To find a radian, we need the length of the radius and wrap it around the circumference of the circle. This length is equivalent to 1 radian.
Now, what is the difference between a radian and a degree? A degree is based on the amount of rotations that two radii make, while a radian is based on the arc length produced by each angle.
The sum of 3 radians is in the same length as 1/2 of the circle, so we add the 0.14 to make it equivalent to pi. That's why a full circle is the same as 2 pi.
A way of thinking about this is to imagine that you're standing in a circular park and you go for a walk around the park, which is through the outside of the park, which is 6.28 radians, or walking 360 degrees around it, which is the same thing.
Good morning, we are Group 5, and today we are going to present a problem where we need to use pi in a real-world situation. Juan is a 22 years old architect who needs measurements to create a lighthouse to help the fishing boats to find the shore. We need to manage to the tower using pi.
The lighthouse is made up of a cone at the top and a cylinder at its base. The formula for the cylinder will be pi times radius squared times by the height. The formula for the cone will be 1/3 times pi times by the radius squared times by the height. The radius of the cylinder is 8 meters and its height is 15 meters. The height of the complete figure is 23 meters. The first thing we need to do is subtract the height of the entire figure by the height of the cylinder, which would give the height of the cone, that is 8 meters. And we know that the radius of the cylinder is 8 meters. This will be the same as the radius of the cone, so we could start solving the problem.
We are going to start with the cylinder since it is the base of everything. The volume of the cylinder will be equal to pi times 8 squared times by 15. This will result in the volume of this figure being 3015.92 meters at cube. The volume of the cone will be equal to 1/3 times pi times 8 squared times 8. That is the result of the subtract of 23 less 15, which is equal to 536.16 meters at cube. At the end, we add the two volumes and we will find that the volume of the entire lighthouse, that is 3,552.8 meters at cube.
Thanks to P, one was able to find the exact site to create a lighthouse, thus helping on all the local finished both. Where we use P in the formula of both figures, both a cone and the cylinder, so it's verified that P is usable for a lot of measurements in objects and to find the volume of the figures. Thank you for attending, and I hope you have learned something.
Good morning. Today we are going to show you how you can present pi in real-world problem. Felipe needs to know the measurements for the semi-sphere so he can build the dome climber for the kids in the playground. In order to solve the problem, we have to apply the formula for a semi-sphere, in which you will see the application of pi in this problem.
To solve this problem, we need to apply the formula for it, which is 4/3 times pi times radius to the power of 3. We have already measured the radius, which gave us 64 centimeters, but now we have to substitute the necessary values and do the math. 4/3 times pi times 64 to the power of 3 gave us 1,098,066.10, but we're not finished. We need to divide by 2 because we use the formula for a full sphere and we have a semi-sphere. So 4/3 times pi times 64 to the power of 3 divided by 2 gave us 549,033.21 cubic centimeters. And now, my partner Alexander will explain to you the application of pi in this problem.
Pi has several use and functions depending on the problem you are solving. In the case of our problem, the function that pi does is very basic since it is multiplying. So we apply the formula of the semi-sphere, which has pi integrated, and we multiply pi by 4/3, and we also multiply pi by 64 to the power of 3.
In this video, we show you how pi can be used in a real-world problem. We also show you the formula to get the volume of a semisphere and how we apply the values to the formula. Also, how to execute them, which with the help of pi, we found the solution to Felipe's problem.
Today, we're going to solve a real-world application of pi. In this case, we'll be using a fire extinguisher to calculate its volume.
Our first step is to recognize that the object is a compound shape. It's made up of a cylinder and a semisphere. Our second step is to measure according to the formulas that we'll be needing. In this case, we'll need the formula to find the volume of a cylinder, which is pi times radius squared times height, and formula to find the volume of a sphere, which is 4/3 times pi times radius to the power of 3. We'll need the shape's height and radius.
We have the shape height that is 39 centimeters. We have the diameter that is 13 centimeters. For this operation, we need the radius, so we have to divide the diameter by 2. That is 6.5 centimeters.
Now we have to start properly with our formulas. Volume equals pi times radius squared times height. Then we have to put the radius, that is 6.5, and the height, that is 39 centimeters, into our formula. Now we have to multiply radius squared. That means 6.5 by 6.5. That gives us 42.25. For the final step, we have to multiply the result of radius squared times height by pi. That gives us 5,176.55 centimeters cubic. Now we have the volume of our cylinder.
Next, we are proceed with the formula of a semisphere. The formula we are going to use is 4/3 times pi times radius squared. We have to multiply the radius, that is 6.5 to the power of 3. That will give us 274.62. Then we have to multiply that by pi. That will give us 862.75. Then we have to multiply all that by 4/3. That will give us 1,100.34 centimeters.
We can forget to divide it by 2, since it's split in half.
After we divide it by 2, our last step is to add both of the volumes, which will give us a final result. Volume equals 5,751.72 cubic centimeters.